Okay, so my name is Rino, and first of all, welcome to this Planeo-software presentation. Today's topic will be a Wetplan, our software for water distribution network design, analysis, and hydraulic calculation. In the following, let's say 45 minutes of live presentation, I will show you full workflow from the creation of the network in plan and profiles to hydraulic calculation and exporting of 3D BIM model to IFC. So as you can see here in this drawing, we basically have just this raster image of this area in Croatia where we are going to design this water distribution network. And also I will show you later, I also have one DTM in the drawing. But in Softplan, even if you don't have anything to start with, you don't have maps, you don't have DTM, you can always get them directly from Google Maps. So if you go to Tools, you can go to import from Google Maps, and you can go directly to Google Maps and search for the area that you are designing. For example, this is in Croatia, so you can just type in the Google search the area, and then you can download the map and also 3D points with elevations for that area. Or, which is a different approach, you can go also to this import from Google Maps function, but you can define the area inside BricsCAD. So first of all, you have to know and define the coordinate system. For Croatia, this is Balkans, zone 5. And now you can select a polyline, draw the area, or select the current view of the screen. I will draw the area. For example, I need the maps here, like this. And now you can define the zoom factor, which will result in the number of rasters that will be downloaded. Also, we can create CAD clipping boundary around this border. What we can download the raster images and also points, but like I said, I already have DTM created, so I will download just the rasters. Let's click import, and from Google Maps, these maps will be downloaded and inserted into this drawing as XREFs. So we can see the area, we can see that the position is correct, we can see how these roads are matching with this existing map that I had before. So that's how you can get the information about the terrain and also the maps that you need. Now I will open the layer manager, and I will turn off this raster image. I just wanted to show you that you can download them if necessary. Here I have also on this turned off layer, I will turn on this DTM layers. These are the source 3D points with elevations and lines that I use to create the DTM surface. So when you work in Softplan, there is 3 types of DTM that you can use. First, you can use directly BricsCAD DTM. Second, you can use our own DTM modeler, which is called Terraform, that I used here. So I can show you the surface that I created. So we can also go to 3D, and this is the surface that I created using those lines and 3D points, and this will be our referent DTM to design this water distribution network. The third way that you can use is if you have some 3D faces, let's say created with some third software, you can also use those 3D faces as DTM. But also in Softplan, if you don't have the DTM, you can also work and basically define the terrain elevations manually. Because we have the DTM here, we will of course use it. Okay, so again, let's go now to the layer manager of BricsCAD, and I will turn off now this DTM layers, and I will open some helping layers that I have, which will help us to design this water distribution network. I didn't say this, so as you can see, we are here in BricsCAD. I'm using version 23. We are always supporting the latest 3 versions of BricsCAD. And you can see Softplan user interface. So on the left, you can see our workspace. Here on the left are the module selections. And of course, on the ribbons, we have 3 custom ribbons, so to work in plan, to work in profiles, and also to work with parcels or polygon topology. Okay, so let's now design this network. So to draw the network in Softplan, there are three main ways how you can draw the network. First way is by interactively drawing in plan. Second way is by conversion of CAD elements such as lines or 2D or 3D polylines like we have here. And also the third way is by importing from some external source file. For example, this can be text files, shape files, SQL databases, LandXML, EPANET EMP files, and so on. Okay, so first I will show you the standard most simple way, which is interactive drawing. So you can see that basically you can start the commands from different places. For example, to draw, you can start it from the main workspace, or you can click here on the ribbon where we put some of the commands that are most often used. So let's click to draw network elements. This dialog will open where you can set up many different options. For example, you can automatically label the pipes and nodes that we will draw with selected labels. We can automatically set terrain elevations from selected DTM surface. We can automatically place pipe on a constant depth below terrain, and also we can automatically define the pipe diameter and pipe material from the catalog. I will place my pipe to be 1.5 meter below the terrain. Of course, later you can manually precisely define the elevations if this is not necessary. So let's click draw, and I will use CAD OSNAP just to snap to these helping circles that I have here. So this part will be our transport pipeline from the tank to the distribution network, and here we will have a water distribution network that we will convert from AutoCAD polylines or BricsCAD polylines. So let's connect these circles and notice how the elements are automatically labeled with the selected labels that we defined, and also how we are hovering over the DTM. You can see that terrain elevations are automatically read from the surface. Okay, so basically it's just like drawing the lines in BricsCAD. Okay, so I will finish here, and with the right mouse button I will end the command. Okay, so this is the first way how you can draw, by interactively drawing in plan. Now I will close this dialog and I will start the second option, which is conversion of CAD elements. Here again you can set up all the same options as in the previous dialog. So DTM surface, pipe from the pipe catalog. Now I will use a little bit smaller pipe. Of course, later you can precisely change the diameters where it is necessary. Also, for the pipe position, I will define a constant depth below terrain, and notice that I'm defining the axis of the pipe, but you can define any point of the pipe. I'm using axis because when the diameter changes, I would like to have the connection of pipes with different diameters to connect to the axis, but you can do it whatever way you would like to have. Also, we will use the same labels for nodes and pipes or sections. Here is a very nice option because you don't have to turn off and turn on layers. You can just use this layer filtering like this. Pick on some line, the software recognizes which layer this is, and now we can freely select the entire drawing, and the software will select only elements on that layer. And now when we click convert, everything will be quickly converted from plain BricsCAD lines or polylines to this intelligent Softplan elements, which are nodes and sections. And we can see that each element is automatically labeled with the defined label configuration that I selected. Okay, so now that we designed the network, let's again open the layer manager, and I will turn off these helping layers so we can focus just on the Softplan elements. And the best way to analyze the network is always by using the data tables, these previews. You can run them in two different ways. First is by just double clicking on the table, but if you open the preview like that, then it's just a preview. You cannot click anywhere else. But there is another way how you can open it, like this, show data previews, where now they are like flexible data tables and they can be on the screen the whole time. As you can see, everything in Softplan is designed with this so-called configuration. So you can see that each function, like data tables, labels, profiles, theme maps, cross sections, and so on, everything can have multiple, we call it configurations. These configurations are basically previously defined and saved sets of some data, parameters, settings, and so on. So you can use defaults, you can create your own, you can store them, and later use them on any other projects. So for example, for the data previews, you see I have this 9 data tables, 6 for the pipes or sections and 3 for the nodes. And here you can switch between these data tables. Also, we have a special sets of selections to use in all the functions. Selections are located here. Usually they are marked with this yellow button, which means select the whole system. But also you can select parts of the system. For example, just some nodes or sections. So for example, if I go to section, in Urbano, section mean one pipe, but it doesn't have to have actually defined the pipe from the catalog. So when you go to selection of sections, you can see that you can select any pipe from the plan or profile. So I will select, for example, these 3 sections, and now I have data just for those 3 sections here in the data tables. But also we have much more intelligent selection options. For example, one of them is branches, and now you can see what is a branch in Softplan. So branch is basically, like the word says, branch is everything in between branching. So in between starting or ending nodes and branching nodes. So this very much helps with the selection, for example, when inputting or editing data, because you can select multiple elements at once. So for example, I will select these 3 branches and I will get the data for all these sections in the data table, or I can switch to a different data table, for example, branch geometry, where I can see the total data for the entire branches. This temporary graphic, you can always delete it, these markings. You can delete it by clicking on this clear broom icon. Also, we have something that we call arrays. Arrays are basically arbitrary topological elements that are larger than branches, and they represent the original CAD polylines if we converted the system from CAD, or the original, let's say, pipe run from where we started drawing to where we ended drawing. So for example, if I now select these 2 arrays, I will get all the sections and all the branches that belong to those arrays, but also I can switch to a special data table according to these arrays, and now we have these 2 arrays. These arrays, this topology can be edited. Of course, you can merge them, you can break them and create your own topology. So for example, if I select these 2 arrays, you can see that they are now not connected, because this one we draw interactively and this one was converted from the CAD polyline. So to merge them, we can go to function for edit of the arrays. I will use function merge. So I will select this one and this one, and I will merge them to array A1. You can give it a name. So let's click apply, and now you can see that this is one array. Also, let's now select all of them and let's rename some of them. So we can later we can draw the profiles according to these arrays or branches. So these names will be very important to know where we are located in our model. So I will use again from edit arrays function, rename automatically option, and I will select these 4 horizontal arrays, and I will give them a prefix H, like horizontal. You can use the names how you like. So let's click apply, and also let's select these 4 vertical ones, okay, and I will give them the prefix V. Okay, let's click apply. You can, there are many different functions for automatic renaming according to some rules. You can use various naming standards for sections, for nodes, for branches, for arrays. But for now, let's keep it simple. So now if we sort it by name, we can see that this will be the array A1. We have H1, 2, 3, 4, and also these 4 vertical ones. So now that we know everything about this topology and selection options, let's draw the profiles. So to draw the profiles in Softplan, it's extremely easy. So basically, you just have to select the profile configuration that you would like to use. And inside those configuration, everything is stored from the scale, from the data, from the language, color, basically everything. So just select the profile configuration. And now you have, again, selection options. I will select the whole network, but we will draw them according to arrays. You can choose between branches or arrays, okay? And you see the names that we given those arrays. We can define number of rows and number of columns, and also row and column spacing. And now when we click draw, we can place those profiles anywhere in the model. So this is the quickest way how you can quickly draw the profiles for the entire network at once. But also you can use the option from node to node, where you can basically go from any node. Let's go from the starting node. We can go from any node to any node in any direction. But I would like to go through this node all up to the last node of this system. Like that. Let's click draw and let's place again this profile here. So let's take a look now at those profiles. And like I said, everything can be customized. So all the data, all the colors, basically everything, how would you like your profiles to look like? So for example, let's change something visually, graphically, and to edit profiles, it's again very easy. So I will go to function edit configuration. You can also right mouse button here and edit, but I like to use this quick commands from the ribbon. Just select the configuration you are editing. And now, because there is a lot of parameters that can be changed, we have this very nice option, interactive select. So you can pick anywhere in the profile. For example, I will pick on the terrain line, and the software will take you where this data can be changed. So for example, I will change the color of the terrain line from the green to, let's say, I will use some brownish color like this. And without exiting the editing mode, you can click apply and take a look at the changes. Or for example, we can pick on a pipe and maybe change this inner wall of a pipe from dashed line to continuous. So basically everything can be changed to look completely different. To show you that, I will open the function profile manager, where you can do many different things with the profiles. And one of those things is to change the configuration with which you have drawn your profile. So maybe you can have, I don't know, one configuration that you are using for designing, and then when you have to submit your project to the clients, you can change the language, change the visual style of the, change the data that you need or something like that. So you can select all of them, but I will select just this first one, okay? And I can change it. For example, I will change it to German configuration, and it's very quick. And now you can see it's in a different language and it looks completely different. So I'm just wanting to show you that you can basically change any smallest detail or data. Or for example, I will use this one in different scale. This one from some of our users from Greece. So again, now you can see it's a larger scale. Now it's 1-to-1 with the plan, and these one are 10 times smaller, because different users, different wishes. In Softplan, you can do all of that. So now again, you can see different configuration of the data, different visual style, completely different. And also I would like to show you one more. This one is from our users in Croatia. Again, smaller scale, again, different look and different data. Okay, now I will switch it back to the default one, which is from the standard English installation. Okay, now that we take a look at those profiles, you can remember that I defined the pipe position to be on a constant depth below terrain, 1.5 meter. I defined that the axis of the pipe is 1.5 meter below the terrain. And I did it for the axis because, like I said, where the pipe diameter is changing, we can see, for example, here the pipe diameter is changing. The pipes will be connected at the axis. But okay, these are very small details now. Okay, but what I wanted to say that even if this solution is not satisfactory, you can define the pipe position very precisely or numerically through the data tables or directly in the profiles. So there are many options how you can do that. I like to use this option for inputting and editing, but also you can open the data tables. For example, we can switch to this section geometry data table. You can select a profile, for example, this one, and here all the cells that are white, you can change directly through the data table. But there are many better ways how you can do it directly in the profile. And also to help us in the profiles, we can also draw these auxiliary lines, and I will use them to draw terrain parallels. One will be 1 meter and one will be 3 meters below terrain. So let's draw them. Okay, let's use all profiles and let's draw them. Okay, so these are just some helping lines. So we can see, for example, if we are somewhere too shallow or too deep below the terrain. And with this editing options, we can, for example, select the entire profile or from node to node. I will go from this node to this node. And now you can precisely define starting and ending depth or elevation, or starting or ending depth and elevation and slope. For example, let's define this to have a constant slope of -5 per miles. Let's click apply, and now you can see that the data table is automatically updating, the labels automatically updated, and also the profile will automatically update as well. Let's now select this part, the following part, from this node to this node. And now I will switch back from by slope to by line, and I will define the ending depth in this node. So let's define the depth of the ending node to be exactly 2 meters. You see with this temporary graphic how the solution will look like when we click apply. And now we see that we fixed this, let's say, problem here, and our pipes are not too shallow anymore. Of course, you could continue now editing all of these profiles and making very precise solutions, but let's say this will be our final position of the pipes. So let's go again to draw these auxiliary elements, and I will delete these helping lines. Okay, so the next step would be to define air release and washout valves. So to do that, I will switch to this Wetplan panel. And here you have all the commands that are related to, let's say, hydraulic calculation and hydraulic modeling. And first of all, we have this air release and washout valves, where you can, of course, manually define places where you want to place them, or you can do it automatically by just selecting the entire network and click apply. The software is searching for the highest and the lowest inflection points and automatically defining this. So this in the lowest point, it will be the washout valves, and in the highest points of the network where the slope is changing, it will be the air release valves. And of course, if we go to plan, so these are custom blocks, everything can be customized. If we go to plan, you can use this icon, select some node in plan, in profile, and you can zoom to plan. And here you can see that also we have the custom blocks appearing for this, let's say, type of the node. So for the elements, for these nodes and sections, we are not using some intelligent objects. These are plain BricsCAD lines and blocks, or you can even change the visual style not to have lines and blocks. You can have the real 2D style or even 3D style with 3D solids. I will show this later. The next step would be to define manholes. So this is not necessary, it's optional, but I like to define manholes where I have this branching in my system. So again, we can go to input data or directly to the ribbon to the manholes dialog. And in Urbano, in Softplan, we have many catalogs. So catalogs are located here. So you have a catalog of manholes, catalog of pipes, catalog of trenches, basically of everything, where you can precisely define these objects. So you can define type of the manholes, materials, dimensions. The same is for pipes, for trenches, for everything. Okay, so I will use this rectangular manhole with rectangular open, and I will select from plan, I will select this branching nodes where I would like to place the manholes. So you have to be careful when selecting, not to select some wrong node. So I will zoom in a little bit to select these nodes with branching of the elements. And like I said, this is just for the visual appearance of the detailed design. It will not have any effect in the hydraulic calculation because we are doing it with EPANET. So I selected those nodes, so I will just click save. Okay, but this filter is turned on, so I will turn it off and click save. Okay, so now if we go to our profiles, we can see that we have the manholes defined to selected nodes. But if we go to plan, you will see that nothing changed. Nothing changed because we have the default style applied, where, like I said, the sections are lines and the nodes are plain BricsCAD blocks. So we can change the style. I will change it to 2D style. Let's select the entire model and let's click apply. And now you can see that we have 2D style of the pipes. So we have the real pipe dimensions, and also we have the real dimensions of the set manholes. You can also define that plan style to be default. So when you continue to drawing, this style will be used. Okay, now if we go to profiles, also we can see that we defined the manholes where we have branching of the network, but also we can define the manholes for this air release and washout valves. So to do that, I will now select the entire system, and I will now use this node type filtering to select just the air release valves first. Click save. You will see that the manhole will appear, and also I will do the same for washout valve. And that's it. So let's say this is the first thing that I wanted to show you, which is I would say detailed design. And now I would like to switch to a second drawing, which is basically this same project, but I predefined some stuff. And now I would like to show you hydraulic calculations and modeling. So first of all, let's go back to this Wetplan panel, and I will define a water tank with this hydraulic node equipment. Like I said, the Wetplan works with the EPANET engine that is built inside. So you can use all the EPANET available equipment and also all the available EPANET hydraulic calculation options. So first of all, select a node. I will select this one here, and I will set it up to be a water tank. Here you can see all the valves, pumps, emitters, tanks, reservoirs, so everything that is available in EPANET. I will select a tank, and you can define the parameters of the tank, but I will leave it as default. Let's click apply. You can see that the custom block appeared in plan, and also the custom block appeared in the profile, showing us where we defined the tank. Okay, the next step would be to define a water demands. So let's go to a function for defining water demands, where you can use many different types of water demand calculation. First of all, I would like to show you this percent calculation where you can define the area. Let's say I will use CAD selection to select this part that I said that will be our distribution network. Be sure to select all sections like this. And now for the selected area, you can define water consumption per inhabitant. Let's say 180 liters per day per one inhabitant. Actual number of people living on selected area, let's say 5,000 people. And now you can define some other parameters like population increase per year, design period, coefficient of variation per day and per hour. And when you click save, the software will automatically calculate and distribute these flows to the nodes as a demands, because we have to send the EPANET water demands set in the nodes. So this is automatic, let's say, distribution of water demands. But of course, we also have the standard way of inputting demands, which is point demand. So what you can do, you can just select some nodes, again, from the plan or from the profile. Let's say like this. Doesn't have to be a branching. And now you can define the same value to all selected nodes very easily, or I will reset it. You can go through the data table and define precisely different values for each selected node. Okay, I will again reset it because I would like to define just one point demand, let's say to this node here, and I will say this will be some kind of industry 6 liters per second. And you can create any amount of this, let's say, consumption categories, and later you can even group them in some kind of water demand scenarios. But for now, let's keep it simple. These will be our basic water demands. So let's now do a hydraulic calculation. So let's start the function for hydraulic calculation. And here, if you go to options, you can see that you have all the EPANET available option. We use the EPANET 2.2, which is the latest release. So you even have this demand model, so demand-driven analysis or pressure-driven analysis, which was added to the latest version of EPANET. I will keep everything as default. I will just click calculate, and notice that each time you click calculate, this EPANET EMP file is created. So it's like an export, but you don't have to open it if you don't need it. But if you want, you can open the EPANET file in EPANET, or let's say in some other software that supports EMP files. When I click open, I can open it in EPANET if I have it installed on the computer, and you see that we have the same network here, completely defined. We see the terrain elevations, or these are the pipe elevations that we defined on a constant depth below terrain. We see these demand categories that I defined. So this is the population automatic distribution of the water demands, and this is the point demand that I defined of 6 liters per second. Okay, let's close EPANET. We basically don't need it. And let's just click save. And you will see that the complete model will automatically update. So you see that in the profiles, these piezometric lines automatically appeared because they are turned on. If you don't want to see them, you can of course turn them off. And also if we go to plan, we can add very easily the data to the plan labels. So let's apply for the sections length, diameter, flow, and velocity. Select the entire system and apply it. And also for the nodes, I will use this name, demand, head, and pressure label. Okay. Also, we can open the data tables. I can switch to a different data configuration, section hydraulics. You can mark in plan, and also you can zoom to plan. And you can use standard selection options. For example, let's select this area here. And now we can automatically zoom to any selected element, and we can check the hydraulic calculation data simultaneously in the data tables and in the plan. So you can see the standard section data like flows and velocities, but also you can see the pressure data for starting and ending node. Okay, let's turn off auto zoom. Sometimes it can be a little bit too much, this constant zooming. Okay, and let's select the entire network and let's sort it by velocities. So we can see that the software is automatically marking in red some values that are too low or too high. Of course, you can define your own ranges. And we can see that we have some very, very small velocities, smaller than 0.1 meter per second on these places here. And also we have some very high velocities on these parts here. And this is because we defined the pipe diameters very roughly while we were drawing the network. So for this part here, I used 315. And for this part that we converted from CAD elements, I used pipe of 160. But of course, we can size the network with a special command. Again, let's go to Wetplan panel. And here is the option for pipe optimization or initial pipe selection if we don't have any pipes defined. And here, this is very nice option because you can divide your network into, let's call some kind of groups, which I did already in this drawing. So this is my transport pipeline, and this is my distribution network. You don't have to do it, but you will achieve better results if you split the network in parts. So for this part, for each part, you can define what is your target velocity, and also you can select which pipes from the pipe catalog will be used for each group. So for the transport pipeline, and also this target velocity can be defined as a single value or as a diameter dependent value. So I will use the diameter dependent value. So for the transport pipeline and also for the distribution network, I define different possible pipe diameters. So for the transport pipeline, we are going from 200 to 355. And for the distribution network, we will have smaller pipes from 110 to 180. So you can choose any pipes that will be used in calculation. So when you click start, this calculation is using genetic algorithm method to achieve the best possible solution. So it takes a few seconds to calculate depending on the size of the network. And now when we click save, we have the results. We can check them. For example, let's select these two arrays. So how this calculation works. So we defined what is the target velocity, and this is the resulting velocity. So the software is trying to achieve that the difference between the real velocity and the target velocity is as small as possible. So we see that in this part of the network, we achieved the perfect result. The difference is 0. The target velocity and the real velocity is 0.80. And somewhere we have a little bit of bigger difference, but this is, again, it's impossible to achieve that everywhere you have the exact velocities as you would like to have them. But now if we close this, you can see that automatically everything updated, our piezometric lines updated, also our pipes updated. So, okay, for example, here, now we have 280 pipes. So the style automatically updated and all the labels automatically update. Let's also take a look at our data tables. Now, if we sort it by velocities, okay, again, we have some small velocities, but these are in these ending parts of the network, which is okay to happen. And we see that now we don't have the velocities that are too high anymore. Also, if we switch to the node hydraulics data, we can check the pressures. So for example, we have some pressures that are, let's say, really low, but they are here outside of the distribution network, close to the water tank. So this is okay. But if we check the biggest pressures, we can see that the pressures that are higher than 70 meters or 7 bars are happening here in this lower part of the network. Another great way how you can graphically analyze these results is by using thematic maps. So again, I have my configurations. I will use for the sections theme maps for the velocities. Select the entire network and click show. And also for the nodes, I will select the pressures, configuration for pressures, and again, select everything and click show. Okay, additionally, we can also draw the pressure contours. So let's do it. The by default, these color ranges are the same as for the thematic map for the pressures. So when you click draw and save, you will see this legend will match these pressures for the this node graphics and also for this pressure contours. Okay, so obviously we have some very big pressures happening in the bottom part of the network. So let's place one pressure reducing valve. First of all, let's delete these theme mappings because they are not dynamic. They will not update by itself like the rest of the program. So let's go to this node here. Let's go back to the Wetplan panel, hydraulic node equipment, and let's select this node here. And let's set it up to be a pressure reducing valve with reduced pressure setting of 35 meters. Let's click apply. The values didn't change because we have to rerun hydraulic calculation. So let's go to hydraulic calculation, calculate, save, and now you will see that the pressure here dropped to exactly 35 meters. And of course, our profiles automatically updated here in the position of this pressure reducing valve. Okay, now I would like to add one firefighting demand. Let's again go to water demands. And for firefighting demands, again, you can create many different categories, many different, let's say, definitions. I just have for one fire. Let's select a node and I will place one firefighting demand to this last node of the system. And I will define it as 10 liters per second. And now you can also define and create scenarios. So water demand scenarios, or let's call them variants. So I created one with fire where I have all these checkbox turned on, and I have one without the firefighting demand. Okay, and now we can go to scenario preview, and here you can create any amount of scenarios, not just two. So let's turn them on, and now in this data table you can see data by data. This is the table for the sections. The same can be seen for the nodes. So you can check it. So data by data in different colors, or you can see all the data for one scenario and then all the data for the second scenario. And like any other data table in Urbano, you can select it, you can copy it, you can go to, for example, Excel or any other Microsoft application and just paste it, and you have one really nice report of these different scenarios with different hydraulic calculation. So this is just a temporary results here, but if you want to apply some results of some water demand scenario to the drawing so that you can have those results in the labels and in the profiles, we have to go again to hydraulic calculation. And now here for demand, you can have sum of all defined demands, which is basically the same as scenario with fire, but you can also define just some of this scenario, let's say with fire. Let's calculate it, let's save it, and now you will see that that scenario will be applied. We can see it by checking the piezometric line. We have a pressure drop happening here, and also if we go to the plan, we can see that we have higher velocities happening here, which can also be seen in the data tables. If we go to section hydraulics and sort it now again by velocities, we can see that we have some bigger velocities happening in these parts of the network. Again, now we could go back to sizing and get bigger pipes, or we can manually just select those pipes, click edit, and choose a bigger pipe. So there is basically unlimited possibilities. If you have the labels overlapping like this, of course, you can move the labels manually, or you can start one very nice command, which is called automatic label reposition, where you can define some parameters for moving. And when you click apply, all the labels that are interfering will automatically be moved, so there is no more overlapping in the entire network. Okay, so now I would like to switch to the final drawing, which is basically this very same network, but I did another part of the network here. So we added another branch here, and here in the first node with the same function, this hydraulic node equipment, I defined one reservoir, and here in the second node I defined one pump with the pump curve. Okay, and also if we go to the water demands function, you can see that for these same configurations, the same calculations, I also defined a pattern. So we have a population pattern, and also for the firefighting demand, I defined a firefighting pattern. These patterns can be defined here in the define curves and patterns dialog. So you see we have a pump curve defined. It's a simple 1-point pump curve. You can also define complex pump curves. This is the time pattern for population with different coefficients of variation per hour. And you can see that the peak flow will be around 4 to 5 o'clock. And for that same time period, I defined the firefighting demand happening these 2 hours from 4 o'clock to 6 o'clock p.m. Okay, so now everything that we need to do is go back to hydraulic calculation. We can go to options, and I will switch the total duration from 0, which is a snapshot hydraulic calculation, to 24 hours. Let's click OK, let's calculate it, and let's save the results. Now you can see that we don't have just one set of results anymore. We have 37 sets of results. So we have the 24 hours pattern that we define, but also we have something happening in between. So for example, let's go through time. You can see how results are changing. And at some point, which is now, we see that velocities and flows are 0. And this is because the pump stopped working. To check that, the best way is to go to time series graphs. So let's select this water tank, this one here, and you can see how the water level is rising in the tank until it reaches the maximum value, and then the pump automatically shuts off. So we can select also this section right after the pump here, so we can see that the pump is uncontrollably constantly turning off and on. So what we can do is to create a rule. So I will do that. Let's go to controls and rules. And this is a very nice function because usually, let's say in EPANET, you have to write a code. If this, then this. And in Softplan, this is basically done graphically. So you add a rule. I will say pump off, and I will say if this water tank water level is, let's say, equal or above 5, then this pump here will be closed. Okay, and here you see the rule. So if water tank level is equal or above 5, then pump is closed. And let's add another one, which is I'll call pump on. And I will say again, if this water tank level is below or equal 1, then this pump here will be open. So if water level is below or equal 1, then the pump status is open. Let's click OK. Let's go to hydraulic calculation again. Let's calculate it. And now you see that we don't have 37 sets of results. Now we have 28. So for example, let's select this section right after the pump. And let's go to time preview. And we can see the hours during which this pump is closed. Also, we can switch to a data table for the nodes and select the pump. And you can see that during these same hours, the pump is closed. Also, let's go to time series graphs. Let's select our water tank. And now you can see how the water level is rising and falling, now controlled by the rules that we defined. And also you can select the section right after the pump, and you get one really nice graph that you can of course draw in CAD. You can draw it like this, so that you have both values on the same graph, or you can draw it like this to have separate data on the separate graphs. Okay, so this is enough of this, let's say, hydraulic calculation and hydraulic modeling. And now I would like to switch to calculation of the trenches. So to do that, let's go to function for inputting data. And again, from the catalog, I will input the trench. Again, in the catalog, you can define different types of trenches, different angles, different sizes, different bedding, and so on. I will use a standard trench with the 90 degrees sides, with formwork and with sand bedding. And I will apply that trench type to the whole network. Of course, you can have different types of trench as well. Then let's go to input data, and we can define what we call upper layers, which is basically let's say a road or some material of the top of the trench, which is necessary to have the, it's not necessary, but you can assign it to have the detailed excavation calculation volume of the material being excavated. So let's say, I will say that the asphalt is everywhere. So 15 centimeters of asphalt. Again, you can define it in the catalog. But let's say that we will go a little bit specific and define some earth material, some humus material from, let's say, beginning of the network. You can do it from node to node, or even from station to station, if the material of the cover basically is changing in between nodes, for example here. And I will say that here we will have 20 centimeters of, let's say, earth material, because we are not under the road until this point here. And now if we go to our profiles, we can see that the sand bedding automatically appeared. You can of course define the hatch, the visibility, and everything of this data. And you see the two types of top layer. So up to this point, we have two layers of, let's say, earth material. And from this point on, we have two layers of asphalt. It can be defined any amount of these layers. So now that we define the trenches, we can also draw cross sections. It's very easy. Just like drawing the profiles, you have to select the configuration that you will use, and inside of that configuration, everything is stored, from data to colors to dimensions to hatches, everything. So I will use a larger scale, 40:1. Okay, and you can do it interactively on some selected stations in plan or in profile, or you can do it automatically along some selection, let's say along these two arrays. And I will say every, let's say, 25 meters. Okay, let's click draw, and let's place those cross sections here. So it's 55 cross sections, and they are drawn in a matter of seconds. And now we can look how these trenches look. So you have all the data, so all the cross-sectional areas for each cross section, and everything is hatched, everything is labeled with these dimensions that are defined in these configurations. So we see the type of the trench, we see that we have the formwork that we defined, and we see the different types of the top layer. Okay, so now that the trenches are defined, we can go to the function for excavation report. We can select the entire network, we can save it, and when the calculation is done, we can open it. It's an Excel report, Excel table, and you can see that it is structured by the arrays, and you have all the data. So for each section, starting and ending station, total excavation volume according to depth excavation zones that you can set up by yourself, for example, from 0 to 2 meter, 2 meter to 4 meter, 4 meter to 6 meter, and so on. Volumes of the upper layer, then sand bedding, pipe volume, sand backfill, ground backfill, formwork area and surface area. This is the top of the trench, and it's structured so array by array. But if you scroll to the bottom of this report, you can see that you have some of the data for the entire network. Okay, so these are the trenches. And now for the last part, I would like to create a 3D BIM model. So first of all, I will apply a 3D style to show the entire network in 3D with BricsCAD solid elements. So if we go to 3D, you can see these pipes and these manholes shown in 3D. It is very important to say that the level of development, level of details, the famous LOD for Softplan models is 300. So everything is in correct dimension, everything is how it should be, but we don't draw, let's say, fittings, we don't draw appurtenances in 3D. We can show them in 2D schematically, but we don't draw them in 3D. In 3D, you can show pipes, you can show manholes, you can even show trenches and the backfill layers. Okay, and now let's export this to IFC. So let's go to our BIM panel, where you have the functions for import and export to IFC, to Navisworks, to LandXML. I'll go to IFC export. We will export the network and also the DTM surface, and also we can export the data. And you can create these groups of data in this function data configurations, which I already did. So I will select geometry data, excavation data, and water hydraulic data groups. Let's click OK, and let's export this to IFC. The file is written, and now we can open it. You can open it with any BIM viewer. I like to use this free application. You can download it for free. It's called BIM Vision, and it's very nice to checking the IFC models. Of course, you can open it with, I don't know, Navisworks if you have it. So let's hide this. And now this is our model now in IFC. You can select a pipe, for example, and here in the properties, you can see excavation data group with all the data about excavations, geometry data group with standard data like lengths, materials, diameters, and so on, and also water hydraulic data. You see velocities, flows. So even in the BIM model, we are having this hydraulic calculation data calculated with Urbano and EPANET. Also, the data for the manholes are here. Okay, let's go back to our Softplan model. And the last thing that I would like to show you is, for example, let's create another network. So to create another network, click on this icon here, and you can create from system template. I will create, let's say, a sewage network. It can be storm or sanitary, doesn't matter. Let's click on draw. Again, we will use the same DTM surface. Let's define the invert elevation to be 1.5 meter below terrain. I will use PEHD pipe with the nominal diameter of 400. And the pipe reference point for the sewage system, I would like to be bottom inner, so the pipe invert. And for the manhole, I will select circular manhole with the diameter of 1200. So now let's start drawing. I will draw it here, and I will intentionally cross it because I would like to show you that in Softplan, all the crossings and clashes are being automatically calculated. So you don't have to worry about, I don't know, clashing with a pipe or with a manhole because the software is doing that automatically. So let's say I draw another system and I will draw now a profile for it. Okay. Of course, the pipe invert is randomly defined, but actually it looks okay. Maybe on some parts, okay, we should define the pipe invert better. We also have a automatic function with which you can do that, but that's not the point. I would like to show you that the pipes that are crossed are automatically calculated and shown in profiles, so you can see where you are clashing with your existing networks, so you can define your pipe invert around that. So not just here, if you go to our water system, that we define. You can also see the relative positions of the other pipes here. Also, if we go to our intersection panel and open the function intersection preview, here in the data table, you see all the crossings in plan. So this is just a crossing. You see the distance is 21 centimeter between these two pipes, but here we have the pipe clashes between these pipes. So here you can also see the relative position, and where it is a collision, it says that it's a collision, and here our first pipe, which is a water pipe, is below the sewage pipe. So this should also be changed and stuff like that. Also, you see the clashes between pipes and manhole shown here. And also we don't have manholes with manhole, but of course that would appear as well if you had it.